In this video, we will perform the exercise 2 of lesson 6, which is about I2C, as you can see here. And this is the Thinginite one. And we will be taking a look at this ambient light sensor. Here is the data sheet of it. The RGB sensor, color sensor integrated circuit. And you can see that it has a I2C interface. And this is the back view of the Thinginite one, and that is the RGB sensor. We will take a look at it on our Thinginite one device as well, not only on this picture. You can see that this is the list of the registers that we will work with throughout this exercise. You can see that we will focus on 4 certain registers. The first one is system control, the 2 mode control registers, and the red data register. You can see them right here. So we will modify the first 3 registers, and we will be reading from the last one, red underscore data register. So we will have to do some settings with changing the values of the registers, mode control 1, mode control 2. And then we will be able to make a burst read starting from the red data. So we will get both red, green, and also blue data. So this is the repository for the exercise that we will follow in lesson 6, exercise 2. And you can clone these directories to your local directory, as I did. So we can open Visual Studio Code, and we will be adding an existing application, and we will point to this local directory that we have, lesson 6, exercise 2. And you can see that we have boards list, source directory, we have main.c, we have cmake_list.txt and project.conf, as we had in the previous exercises as well. So we'll modify the project.conf file with enabling I2C. Remember that we had done this in our previous video to enable UART. This time we are enabling I2C, and we are saving our project.conf file. And we will include the header of the I2C API in main.c. And we will be continuing to make modifications on the main.c according to the steps in the exercise. So we will have printk.h, we will include that in our main.c as well, because we will be using the printk function to create outputs on the serial terminal. In this one, we will not make any actions because in our DTS file, we already have our sensor. You can take a look at your common.dts file in this location, and in under I2C, you will find the RGB sensors section, BH1749. You can see it right here. So we will get its node identifier with this line. Again, we are pasting these instructions to their relative locations in the main.c. So we get I2C DT spec get, and we will define the register addresses. Remember that table we had in the beginning of this exercise. You can include it in a separate header file, but as the exercise says, we will do it in the main.c file, not to make so complexity. These are the registers and their addresses, and this bit 4 is for enabling the RGB. And we continue with the instructions. On step 9, we make the changes to the mode control 1 register, and to read the RGB values, we will get this section and we will put it under step 10. And at step 11, we are going to make a burst read starting from red data. We will get 6 bytes. You can see its structure starting from the most significant bit, ending at the least significant bit. You can see this code section here. We are getting the first, for example, RGB value 0, and then we are getting the RGB value 1 and shifting to the left by 8 bits and creating the whole variable to be printed. And we create a build configuration. Now the build process is complete, and let's take a look at the RGB sensor on our own device. So it's at the back side of it. I don't know if you can see it clearly, but you can remember the picture. This right here is the RGB sensor that we have right there. You can check it with the picture of the exercise as well. And this is our battery and the connection to the board. You can extend that middle section of the board to take the board out of it. Now let's open the NRF Connect for desktop and let's open the programmer in order to load our hex file to the device. Let's connect our Thingy:91 to our laptop first. After connecting it, let's put it into DFU mode by pressing the button and turning the device on at the same time. And let's select our device first, Nordic Thingy:91, and then let's go to the folder of our build, appsite_.hex. Let's click on write, and you click on write once again. And our code is written to our device. Let's turn it off and on in order to make the code run on it. And now let's open PuTTY, our serial terminal. Our device was at COM7 and the default speed is 115/200. Let's click on open. And you will see that we have 3 values for red, green, and blue. And the values you see are in decimal numbers. And as you can see, if I shade that part of the device, you can see that the values drop significantly and we have some light. And when I turn off the light, you can see that the values are minimum 1, 4, 3, and etc. And on this iPad, I'm going to use this random color generator, and it's going to help us to test if our RGB sensor is working properly. So I'm going to put it on the table and I'm going to put the sensor on it. However, you see that the values we have on this application is hexadecimal. So right now we have 590E, E0 as RGB values respectively. According to my experience, the green values, for example, for this one, we have very low values both on the application and the sensor's reading values. As I said, according to my experience, the green values are much more close to the values that the sensor is giving us. And you can use your calculator in order to compare the values of the application and the values that the RGB sensor is showing us. Okay, in this one as well, for example, we have the green tone. You can see that the green value is high in this one as well. Now let's change our code so that we will have hexadecimal output instead of decimal output on the serial terminal. So we write X instead of D in our print case section, and we create another build for this one. So it will build _1, and we click on build configuration. Now that our second build is complete, let's put the device again in DFU mode. And we can choose our device once again as Thingy91, choose our build as build _1 Zephyr app _sign.hex. So we write our code to our device and we'll turn the device off and on once again. Okay, we can open PuTTY. You can see that at the moment we don't see it, but we will see hexadecimal values. You can see that we have 3B and we have other hexadecimal values, 3C, E5. So we will be able to better compare the output on the iPad and on the output of the sensor.